Did you know there's an integral symbol that has a funny-looking 3 in the middle? Well, if you're taking calculus, you probably already know it as the triple integral symbol. But before you start thinking your teacher is playing some kind of weird math prank on you, let me explain. In the late 1600s, two very smart people named Isaac Newton and Gottfried Wilhelm Leibniz were working on something revolutionary, a new way to solve complicated math problems involving things like speed and area. They didn't know it at the time, but they were creating the field of calculus. And although Newton is the name most commonly associated with calculus today, it was really a joint effort between these two geniuses. Okay, wait, what? What do you mean? How could anyone else get credit for inventing calculus? Well, it turns out that both Newton and this guy, Leibniz, independently invented calculus without knowing about each other's work. But despite inventing the same thing, their approaches were very different. And as you might have guessed, this led to a bitter argument between them over who deserved the title of the inventor of calculus. Today, their argument is known as the calculus controversy, and it's considered one of the greatest intellectual feuds of all time. So let's learn about the man behind this notorious argument and the contributions he made to mathematics. This is a portrait of Gottfried Wilhelm Leibniz painted by a famous German artist named Anton von Webern. In the portrait, Leibniz is shown wearing a black coat and a white lace jabot around his neck, which was a type of stiff collar that was fashionable at the time. He's sitting in a chair and holding a book in his right hand, and there's a globe and an open book at his feet to symbolize his intelligence and scholarship. But let's take a closer look at his face. Notice his intense gaze, his high forehead and his neatly trimmed beard. There's a lot going on there. So let's try to read his face. According to the textbook, Physiognomy, which was popular at the time, people with large foreheads were thought to be quick learners, while those with long, narrow faces were considered to be deep thinkers. People with strong chins were seen as ambitious and determined, and those with heavy eyebrows were thought to be passionate and intense. So when we put all of these features together, what does it tell us about Leibniz? Well, according to Physiognomy, he was a brilliant and ambitious mathematician who was capable of great passion and intensity. Of course, it's important to remember that physiognomy is not a real science, and these ideas about what different facial features mean are based entirely on superstition and prejudice. But it is still interesting to see how people used to try to make sense of the world around them. So now that we've learned about the artist and the painting, let's talk about the man himself. In 1646, Gottfried Wilhelm Leibniz was born in Leipzig, Germany. As a child, he was considered a prodigy. By age 5, he could speak Latin and Greek fluently. By age 10, he knew most of the major mathematical books. At age 16, he graduated from university. But he never stopped learning. Throughout his life, he studied everything from philosophy to law to theology. But his true passion was mathematics. When he was 22, he came up with a new notation for representing fractional exponents. It may not sound like a big deal today, but back then it was revolutionary. No one had ever represented fractional exponents before. That is, exponents like 1/2 or 2/3. People had worked out how to deal with them, but there was no accepted notation for writing them down. Now, thanks to Leibniz, the expression x to the power of 1/2 means the same thing no matter who is doing the math. The world was becoming a more rational place because of this. At the time, Leibniz was working as a secretary to the Duke of Hanover. But soon he would leave this job to become the director of a new mint being established in Vienna. Here he developed the first mechanical calculator. When you think about computers, you might assume that they were invented in America. But did you know that the first mechanical computer was actually invented in Germany? That's right. Gottfried Wilhelm Leibniz, the same guy who invented calculus, also invented the first mechanical calculator. It is not surprising that he was interested in developing a machine like this since he had always been fascinated by the power of numbers. In fact, he once said, the whole art of calculation consists in the skillful manipulation of symbols. So when he moved to Berlin in 1687 and began working as a mathematician and professor at the University of Berlin, he continued his work on mechanical calculation. And that brings us to one of his most famous inventions, the stepped reckoner. This was a device that could perform addition, subtraction, multiplication, and division automatically using a series of gears and wheels. Unfortunately, only one of these machines still exists today, and it's housed in the Berlin Museum. But there were several other designs that Leibniz worked on that were similar to this one. What's so amazing about these machines is that they were built hundreds of years before the advent of modern computers. And yet they perform many of the same basic functions that computers do today. They add, subtract, multiply, and divide. They store numbers in binary form. And they even have a memory function. Although they're much slower than modern computers, they accomplish the same tasks using mechanical parts instead of electronic ones. So why aren't these machines more well known? Well, it's probably because they were invented by a mathematician rather than a computer scientist, and they weren't seen as being particularly groundbreaking at the time. But in hindsight, they were actually a huge step forward for the field of computing. Now let's get back to calculus. One day, Gottfried Wilhelm Leibniz was reading a book by the French mathematician Pierre de Fermat. Fermat was one of the most brilliant mathematicians of all time, and he made important contributions to number theory, probability, and calculus. And it was in this book that Fermat posed a problem that would occupy Leibniz's thoughts for years. Fermat's last theorem states that there are no positive integers of b and c that can satisfy the equation a to the power of n plus b to the power of n equals c to the power of n for any integer value of n greater than 2. Fermat claimed to have a proof of the theorem, but he never wrote it down. And it wasn't until 1995 that the English mathematician Andrew Wiles finally proved it. But that's not what we are talking about today. What we're interested in is the fact that Fermat's book inspired Leibniz to think about the problem of finding tangents to curves. This is one of the fundamental problems in calculus, and it's the basis for the derivative. To find the tangent to a curve at a given point, you need to know the slope of the curve at that point. And the slope of the curve is equal to the derivative of the function that describes the curve. Leibniz approached this problem in a very different way from Newton. Newton's method was more intuitive and geometric, while Leibniz's was more algebraic and analytical. But both methods arrived at the same result. The derivative of a function is a new function that describes the instantaneous rate of change of the original function. For example, if you have a function that describes the position of an object as a function of time, the derivative of that function will describe the velocity of the object. This is because the derivative tells you how much the output of a function changes with respect to an infinitesimal change in the input. In other words, it tells you how the function is changing at any given point. Let's take a look at a few examples. The derivative of x squared is 2x. The derivative of sine x is cosine x. And the derivative of e to the x is itself. These are all very simple formulas, but they are the building blocks of calculus. They allow us to calculate rates of change, areas under curves and volumes of solids of revolution. They are used in everything from physics to economics to machine learning. And none of this would have been possible without the work of Leibniz. Alright, so now we know what Leibniz accomplished, but how did he fare in the calculus controversy? Well, let's just say that he lost. Although he and Newton independently invented calculus around the same time, Newton published his work first and ended up getting most of the credit for inventing calculus. Leibniz did receive some recognition for his contributions, but he was often overshadowed by Newton. This was partly because Newton was more famous than Leibniz and partly because his work was seen as being more intuitive and physical. Today, however, we know that Leibniz's approach was actually more elegant and powerful. In fact, most of the notation that we use in modern mathematics comes from Leibniz's system. So even though he didn't win the calculus controversy, Leibniz's work has stood the test of time, and he is now recognized as one of the most brilliant mathematicians of all time. Gottfried Wilhelm Leibniz died on November 14, 1716, at the age of 70. He was buried in the Berlin Cathedral, where his tomb can still be seen today. Over the centuries, many famous scientists and mathematicians have paid tribute to him, including Carl Friedrich Gauss, who said, "We are all of us indebted to him who has advanced the ranas of human knowledge." So the next time you hear the word calculus, remember the two men who invented it, Isaac Newton and Gottfried Wilhelm Leibniz. That's all for today. See you next time.